Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion is part 16 of an ongoing series dealing with the topic of operating system deployment in Configuration Manager 2012. Today's discussion will center on the concepts around UEFI, working with UEFI systems in Configuration Manager operating system deployment. There is a reference BIOS or UEFI. Really, that's probably misleading because there really isn't a choice anymore. Manufacturers are moving to UEFI because of the various benefits it has. We're going to talk through it. What is UEFI? What are the benefits? UEFI tidbits, a few things about UEFI that are unique. Then we're going to pull in OSD and how we use it. UEFI, interesting. What is it? It's Unified Extensible Firmware Interface. That's what the acronym translates to. Basically, it's a software interface between the OS and the system. Same thing applies for BIOS. BIOS was a software interface between the OS and the system as well. UEFI is a replacement for BIOS. It's much improved over BIOS. We'll see some of the benefits on the next slide, right? It's funny, these systems probably will always be called BIOS to me because that's what I grew up around. Even a UEFI system, I'll just refer to it as BIOS because in my mind, I think of BIOS as that software interface between the OS and the system. It's just UEFI happens to be the flavor of BIOS. That's really not true, but that's how my mind thinks. Kind of like those of us that have a DVR might refer to that DVR as a TiVo, not because it's the TiVo brand, but because TiVo is what's in our mind as the first one to the scene with a DVR, right? But BIOS is really going away, and UEFI is becoming more and more center stage because of the benefits it provides, right? Certainly for those of us that would like to continue in the BIOS mode, there are manufacturers that provide a BIOS compatibility mode, but it's implemented through UEFI, right? In fact, I've heard of systems that people preferred the BIOS compatibility mode because the UEFI pieces weren't quite where they needed to be, right? And then now I've heard of the opposite, where folks are being kind of nudged into the use of UEFI because the BIOS compatibility isn't what it should be, right? So it's interesting. There are benefits, though, and encourage folks to go the UEFI route, especially now that it's a bit more mature than whenever it first released. The ability to boot from large, greater than 2 terabyte disks is there. Increased speed, increased security, definitely part of UEFI. There's details that you can get around this if you want to look it up. Modern, so the interface for UEFI is definitely got a modern look. BIOS, we all have been there. We've seen the navigating with the keyboard to go between the different sections. Some implementations have mouse support and so on, but it's definitely old style, to navigate a BIOS system typically. UEFI, more modern, looks like you'd expect it to, more so, right? One of the cool things about UEFI 2 is it's CPU independent. Really, it can be applied to any, and it's also probably manufacturer independent. We've all seen different iterations of BIOS that would be provided based on the firmware and manufacturer and all these different variables, right? And UEFI tries to get around some of that, get around some of the fragmentation that BIOS suffered from because of the uniquenesses each manufacturer needed to add. It's a modular system, flexible, pre-OS boot environment, supports GUID partition table, GPT, which is cool, right? And again, it's mature. There's more that you can find in here that you can understand the benefits of UEFI. These are some top-level things that I found. So there's definitely some other things about UEFI that are interesting to note. For example, in Config Manager OSD, the boot image. If you're running on a BIOS system or a UEFI system in BIOS compatibility mode, then you can use whatever boot image you would like. There's limitations, but whatever boot image you would like to initiate the imaging for your system. You could use a 32-bit boot image. You could use a 64-bit boot image to start off the deployment of a 32-bit image. You might have to change boot images. There may be some things in there, but bottom line is it's not really architecture tied. It's not forcing you to use a certain architecture to get the boot done. UEFI does. Your boot image architecture has to match the image architecture, the system architecture, the processor that you're running on, right? There's also differences in if you're running on a VM, like you'll see me do in a minute. Hyper-V introduces what's called a Generation 2 VM. That is the VM built to emulate UEFI, right? One other nice thing has nothing to do with UEFI. About the Generation 2 VM, there is no legacy NIC required for Pixie Boot. You could just add your NIC, turn on the system, Pixie Boot if you want to, and off we go, right? VMware, not a VMware guru at all, but understand that the VMware implementation of UEFI support is in terms of boot mode on a VM. So don't know what that looks like, haven't played with it, but at least that's what seems to be the case. It's not necessarily a different VM type like we have Generation 2 VMs in Hyper-V. Okay, so let's turn our attention to task sequencing and how we support UEFI natively. Right, so we do have native support for UEFI disk partitioning added. Believe it was added in Config Manager 2012 R2. I could be wrong about that. May have been SP1. I just don't recall. But either way, it's there now. And the way that you get that logic added to your task sequences is by using the task sequence wizard. Right, it gives you two options: one for partitioning through BIOS, one for partitioning through UEFI. Some folks who are very advanced in Config Manager OSD don't use the task sequence wizards any longer and have seen a couple of questions come across about, hey, how do we enable dealing with UEFI in Config Manager? And the reason they ask that question is because they aren't aware of the task sequences created by our wizards now because they don't use them. They've gotten advanced enough to not use them. But it's really easy. If you just look at a basic task sequence created by our wizard, you will see full support for UEFI and BIOS. So let's actually look at a standard basic task sequence that's designed for UEFI support. And I have one here. So this is just a task sequence to deploy any old standard image, right? And you'll notice that this is quite a very simple task sequence. And you'll have a section here for partitioning the disk for BIOS if we're running on a system that supports BIOS or a UEFI system in BIOS compatibility mode. We just have the BitLocker partition, the Windows partition, and we also have the partition step for UEFI. And notice a couple of differences. So for BIOS, we're just using the standard MBR for our disk type. For UEFI, we're using the GUID partition table as our disk type, right? And we're carving out 4 different partitions. Now, you don't need the Windows recovery partition if you don't want to have it. It's not a bad thing to have, right? We default choose to create that partition for you, okay? Now, how do we know which way to go? Well, all of that is controlled by variables that are on each step. So the key one here is whether or not we've detected that we've booted through UEFI. So if SMSTS boot UEFI equals true, and all the rest of these, are lining up, we're not OEM media and different things. I'm sorry, not equals true. I said equals true, didn't I? So as long as this doesn't equal true, and this is the key one, the other ones have to be true as well, but this is the key one, we are not booting UEFI, then we're going to go create the BIOS partitions. Whereas if we are in the UEFI step, it's the same 4, it's just now it's equals true, right? So we just choose in the task sequence which way we go. Now, I'll show you this run in a minute. We'll kick it off and we'll let it get through and I'll show you a few things about it. But the question is, how do we actually need to carve up the disk and configure the disk for UEFI booting systems? The answer is, from this, you don't know. You see the partitioning that we need, absolutely, but there's other things we need in terms of building out the boot files and putting files for needed for boot in different places that frankly is just handled automatically here, right? I'll show you that again in a minute. We'll actually run this thing. Actually, let me pull this back out and we'll just switch to the next slide. Okay, so here we're going to talk about 2 ways that we can run this thing. We're going to demonstrate deploying an OS to a UEFI-enabled system. This is fully functional, right? meaning that if you just have a UEFI system that you want to image using UEFI native, fully functional in Config Manager 2012 works beautifully as long as you're on the version of Config Manager that embeds UEFI support. Again, I think that's R2. Could be SP1. I can't remember, but I think it's R2. Fully functional, right? You can deploy it, use the build wizard, inject it yourself, right? There's two levels here. One, the task sequence engine needs to be the latest version, because in there we have certain things that the plumbing is there, so to speak, to detect and work with the UEFI system. It's not just the partitioning, right? That's the point. I'll talk about Prestaged in a minute, right? Prestaged is not functional out of the box. Once you apply the Prestaged image, this is why we're doing this discussion after we had the discussion on Prestaged. Once you apply a Prestaged image to the system and then try to turn it back on, it will not boot, right? If you'll recall, the way Prestaged works is that we will load that WIM onto the hard drive and then turn it off, ship the system to wherever it's going to be, and then turn it on. The system should boot and continue through the imaging process, choose the right task sequence, all that stuff is local, and it's all good. The linchpin in this is once you lay that initial WIM down through the pre-stage process, the system won't boot after you turn it back on, and that's obviously a problem. So there are ways in which we need to go about preparing the system to boot in order for Prestage to work. We'll come back to this in a minute. One key thing, there is a key difference between just standard imaging to a UEFI system and pre-staged imaging to a UEFI system, and that very simple difference makes all the difference in the world as to whether the system boots once you turn it on again for pre-stage. So I'm going to ask the question, I'm going to show you these two side by side in a second. I'm going to ask you the question, what is the difference, right? And I'm going to come back and I'll show you some other references around pre-stage, but let's pull back in the lab for a minute, and let's actually go and start working through this image deployment. So I'm going to cancel this. Oops, let me get this maximized. Come on, there we go. All right, so I have a bare metal system here that is ready to go. I'm going to turn it on and just basically kick off the imaging process for that system. This is a Generation 2 Hyper-V VM. You can tell if you're used to working with Hyper-V because certain options are not here, right? This very much looks like a Generation 2 because we don't have options like the hard disk. All those things that you would expect in the Generation 1 aren't there. So, oops, I missed what I needed here. Let me turn that off. Let me do it again. I need to get it to boot from DVD in this case so we can start the imaging process fresh. Come on. There we go. Oops, hang on. Still didn't do it. You get the boot order. I think the boot order, let's see if the boot order is out of whack here. Yes. Need to tell it to boot from the DVD drive. That's my bad. All right, so let's start it up again. And there we go, connecting, booting from the DVD drive. So this experience will be very much the same as you would have, whether it's a BIOS system, native BIOS, BIOS support in UEFI mode, whatever it is. It's going to seem the same to anyone going through this wizard, right? It's just the plumbing behind the scenes that will make it work differently. So good enough, we'll move forward. We'll select our task sequence for just standard image deployment and let that thing run. I'm going to open the command prompt so that we don't actually reboot. So we'll let that run for a while, get back to the point where the image is loaded and we're ready to reboot into the running OS to continue the imaging process. And we'll come back here and just look at a couple of things before we let it reboot. All right. So turning our attention to Prestage, to be very clear here, There's two ways, or two things that we're talking about. We're talking about standard imaging, where you're just trying to deploy an OS to the box and bring the box up with that new image. That works flawlessly, no problem, right? Prestaged is the only thing that is a challenge here, okay? So the point of that is prestaged is not a common use scenario. It may be, certainly there are organizations that depend on Prestaged because of the uniquenesses that it brings and the flexibility that it brings, but by far the standard OS imaging, as you see in the highlighted task sequence, is more common. That works beautifully. If you're using Prestaged, there are additional things that you need to do in order to make this work, right? So I asked the question, what is it about these task sequences that cause it to work on imaging but not work on Prestaged, right? And there's one very key step in here. So if you look at the one on the left, this is for imaging. We do our partitioning here, and then we do our apply OS here. This is using the apply operating system image step, okay? If we look over on this one, we also will have apply the WIM, because remember, this is the Prestaged part. This is where we're laying down all of the content from that WIM so that we can then turn it on once the system gets to its final destination and the imaging can proceed from there. This step is used to lay down the WIM content onto the hard drive. But notice this is a different type of step. This is apply data image, and this is the kind of step we would use on BIOS, and it would work flawlessly, no problem. Here's the point. In Configuration Manager 2012, the apply operating system image step here is engineered to add the components needed for boot to the hard drive, to prepare that hard drive so that it can boot in UEFI mode. The apply data image step is not, and that's the difference, right? And because that step is not engineered to set up the hard drive the way it needs to be set up in order to get it to boot after we turn it off, we have to set it up ourselves so that it's ready, right? So there's a couple of things. I'll go ahead and close this one out. Here's a couple of things I'll call your attention to. One is a very good blog by Frank Rojas that goes through step by step exactly how all of this works, right, and why it's necessary. So here it is. It's really, really detailed and gives some history, gives some configurations. I know how much of a chore this was to actually do because I was involved with it, right? At the end, the really nice thing, this is great educational material to go through and learn what is required, right? But we also, at the end, will provide a task sequence that actually has all of this stuff baked in, right? In Config Manager 2012, one of the nice things is you can import, you can export just about anything, right? And that's what this is. This zip file is what you saw, and I'll show you again on my system that I simply imported. This is import ready, in other words. Yeah, you'll have to tell it don't worry about the dependencies, and then there's one place, the Prestaged WIM, that you'll need to modify in the task sequence so that it points to your environment. But other than that, it pulls in just fine and gives you what you need in that task sequence in order to successfully create a Prestaged WIM on a UEFI system. Read through this. It's great to tell you how things work behind the scenes, right? So let's go back to our system. So if we look at this Prestaged WIM, you'll see, the various options. Let me open this up a little bit so we can see it better. Oops, come on. All right. So we're going to go through and we're going to restart Windows PE if we're there already. Cool. We have the option to format and partition the disk if we're in UEFI mode. We detect whether we are with this variable, right? We are in UEFI mode. So we're going to go through here. We have a section here where you can format without the recovery partition. If you choose to do that, we just have it disabled here for those that don't want to. If you want to, just turn it on. Right? Then we have the steps. If you want to format with a recovery partition, which is the default way that we do it in ConfigMgr, here's how you would partition. Right? The same little 4 sections that you saw in the imaging task sequence. And then we're going to set a variable internally. We're going to create a variable called recovery partition, set that to true, so that we know that later on. Then we're going to set a variable called UEFI as the boot option, so that we know that because we're again in the UEFI section. And we're going to tell it what the UEFI directory should be. Right? Here's a section where we can format BIOS if we choose to. Again, checking this boot mode is not equal to true. Okay? And then if we go through and partition BIOS, it's the same kind of stuff you would expect. The boot option, this variable again shows up again. We're setting it this time to boot, and we're setting it the directory to boot as well. Again, just setting up the environment. We've just made the decision whether we're formatting for a UEFI system or formatting for a BIOS system. The actual magic of preparing the files for the boot in BIOS and preparing the files for the boot in UEFI will happen later. Here we're just setting the stage and crafting out the user-defined variables to point as we need to. So now that we have the partitions created the right way, now we're ready to lay down the WIM, right? The image package that we want to apply to the disk. We're going to use whatever OS part is the variable name to tell us where we're going to go and image, right? And then once we get that applied, now we have the work to do to get that disk ready to boot once we turn the system back on after shutdown. So now we need to create the BCD store. This is in common whether it is a UEFI system or a BIOS system. So we're going to create our various pieces here. We're going to run our various commands. In other words, here's some variables like the OS part and so on that we do. We're going to delete the boot store and then recreate it, right? Copy out our BCD files, do a couple of BCD edit commands. I'm not going to go through this in detail, but basically we're configuring a lot of the work for you, all of the work for you of doing this. It would be a real painful thing for a customer to set this up on their own, right? Then we're going to create a custom WinPE shell.ini so that we can boot in. Again, we're going to only do this if we are in UEFI mode. So through this process, we're going to go and mount the WIM and make some changes. So the boot.wim, we're going to go ahead and mount that with DISM. All right, the OS part, mount directory, OS part, Windows temp mount, whatever, and get that done. And notice what this is. Again, it's boot.wim. What is that? Is that the WIM file that you're laying down onto the system? No, it's the Windows PE boot, right? So we have that. We've got to make some changes in it. So we've mounted that. We're going to create some different things inside of it, create our disk partition, all of that kind of thing. All right, and then finally create your new INI and so on. On we go, right? So I'm not going to go through every one, but you see there's quite a lot of work. There's quite a lot you could understand about the process from here. Then we're going to unmount the boot.wim and save it and get rid of the mount directory. Right? And if we have a BIOS system, we're going to go through a similar iteration of it, right? Just make sure that it doesn't equal true. Then we're going to mount that boot WIM, make some different changes to it as needed, and then close it up and be done. And finally, we're going to shut down. So after this process, the system should be configured as needed so that we can lay down that WIM, turn it off, ship the system to its final destination, turn it on, and the system boots normally and allows you to continue the pre-stage process. All right. So again, don't be alarmed by this. You know, if you're doing normal imaging, then no problem. We support that out of the box, runs beautifully. But if you're doing pre-staged, which is a corner scenario compared to normal imaging, this is just extra work that you need to do. It's not hard because we give you the task sequence. this is what you will get whenever you import that task sequence on that blog. Right? The only thing that you'll need to change in this task sequence is here. Right? I just needed to specify my specific WIM that I wanted deployed so that I can tailor it for my environment. Right? You can also choose recovery partition or not up here if you choose. All right, let's move away from Prestaged and let's just go back to our imaging system and see. So we're finishing up the setup windows in Config Manager. We should be done almost. In fact, we're done enough that I can show you what I need to, and then we'll let it reboot and prove that it actually boots up. All right. So if we go into disk part, first I want to show that we actually did carve out 4 partitions because we detect this is a UEFI booting system. So I only have one disk, so I'm just going to select disk 0, and I'm going to list the partitions here. Yeah, I'm going to go ahead and let it restart because it's not going to restart while I have command prompt open. Oops. All right, show. I never can get this right. Hang on. There. Okay, I put partitions. So we do have 4, right, that we carve out. We have the recovery, the system, the reserved, and the primary. Not all 4 of these are not visible. A couple of them are hidden, right? So we have this, let me exit. We have the C drive, or in this case, I think it's the D drive, that has all of the information, or actually C drive. Anyway, we have the D and the C drive where everything's loaded down, ready to go, right? We have the S drive, which is a specific drive that we assign for UEFI boot. We have this directory here. So if you would have actually looked at this whenever we first partitioned the drives, the S drive would have been empty. It's the final phase of the imaging process that actually goes out and creates these boot files. If we change directory into EFI, you'll see that we have the Microsoft Store, the boot store, and files in there accordingly. Right? So this thing is ready to go. So if I exit this, it's going to reboot. I'm not going to touch it this time. I'm going to let this thing boot normally. So in the stage of imaging we've just applied the OS. We've just finished or started the setup windows and config manager stage. So we are ready to boot the system again and let the imaging process continue. So you would expect the normal things at this level, the setup or the settings, configuration, so on, to begin working. And you'll see a little spinning bar here show up in just a second. There it comes. So you know that we have now successfully booted from this disk, and we're going to continue the imaging process. You know, if we wait long enough, we'll see get devices ready. This thing will continue running, and so on, right? But we won't. Well, we did. I wasn't planning to, but whatever. Get devices ready. So you see it's going to continue on. And that's really it, right? So just again to draw very clearly the distinction, this section, normal image deployment to a UEFI system, works flawlessly, right? We have the plumbing inside the engine to allow us to know how to create the disk in order to let it boot, fully functional. It's only the pre-stage scenario that is not fully functional out of the box. We make it fully functional to you by giving you that blog post and by giving you that sample task sequence. So use it and leverage it and make your life easier if you're using pre-stage scenarios. Also use it and leverage it to help you understand how the disk has to be carved up for UEFI systems. All right. So with that, we'll end this part. We will continue next time and take the next step in this journey of OS deployment.